What's poppin', dogs? Mr. Allen here, solving some equations in this video, starting super basic and working our way up. So let's start with the first one here. I got x minus 5 equals 10. This is a one-step equation. What do I have to do to get my x alone? I'm going to add 5 on this side to get rid of that 5. Boom, it's gone. But whatever I do to one side, I got to do to the other. I got to balance this equation. So I have to add 5 to both sides, and I get x equals 15. And what I just said there, I got to add 5 to both sides. It's super important because we often start thinking like, oh, I'm just going to add 5 to the other side. I'm just going to add 5 to the other side. We're not just adding it to the other side. We're adding it to both sides. Okay, I got to keep things equal. So if I add 5 to one side, I got to do it to the other side. Now they are balanced here, and I've got x by itself because I got rid of that 5 on the left, and it ended up being 15 over there on the right once I've balanced the equation. Okay. So we're not just adding it to the other side, right? We're balancing the equation when we do this, but we are choosing specifically what we want to add to both sides so that we can get x alone. Now let's look over here at the two-stepper, okay? First thing, okay, I got a 2 here in front of the x. I've got a 3 added right here. What do I do first? Well, I want to get this 2x alone so that then I can divide by 2 on both sides. So I'm going to subtract 3 first on both sides, and I'll get 2x equals positive 12. Now you might be thinking like, well, why can't I just divide by 2 first? You absolutely can. But if I divide by 2 here, I got to do it here and here. I got to do it on both sides so that 3 also gets divided by 2. Now I'm dealing with a fraction of 3 over 2. I don't want to deal with that, right? I don't feel like dealing with fractions, so what I'm going to do first is I'll subtract the 3 on both sides, getting me 12, and now when I divide by 2, even if I'm left with a fraction, it's my final answer. In this case, it ends up being a nice integer of 6. But if it was a fraction, I'm done. I'm already good to go. I don't have to math with it any further. Whereas if I divide it by 2 first here, now I got 3 over 2 that I got to deal with. I don't want to deal with that. So there we go. We got x equals 6 in our two-step equation. Now we're coming along to something with parentheses. Oh boy. We got to do some distribution. You also have the option to divide by 4 on both sides first. I'm only going to take that route if this number is divisible by 4, which it is not. So instead, I'm going to distribute my 4 in. I get 4x minus 4 equals 10. And now I'm essentially dealing with this scenario, right? So in math, what we often do is like, hey, I'm going to transform this guy, if I can, into a problem I recognize. Well, this here is now a two-step equation just like this one. Let's follow the same process. I could divide by 4 on both sides, and actually wouldn't be that bad on this one, but I will get a fraction over here, right? So instead, let's go ahead and just add 4 to both sides. Then we're following a similar process. And I like doing that regardless of everything being divisible or not. I'm just going to subtract the 3 on the other side, then divide by 2. I'll add 4 to both sides, then I'll divide by 4. So now when I divide by 4 on both sides, I end up with x equals 4 over 14. Is that nice? No, but they are both divisible by 2, so I will get 7 over 2 for my final answer. Lovely. So sometimes we do end up with a fraction. It is what it is, right? Math ain't perfect all the time. Well, it's perfect, but it doesn't always end up beautiful, right? We can get some weird answers at times. I know it's like, you're like, did I do something wrong? If I get a fraction, it does happen, guys. All right, last one over here. So I got multiple x's. How do I deal with this? Well, 3x and negative 2x, those are like terms. I can put them together. What is 3 minus 2? It's 1. So I have 1x plus 5 equals 16. All right. So when I combine like terms with my x's, I'm just adding or subtracting my coefficients. The x stays as an x, okay? If I had 10x minus 2x, I'd have 8x. If I have 3x plus 2x, I'd get 5x. The exponent doesn't change on the x, just the coefficient changes. And now I've got, well, it looks actually like a one-step equation because if this is a 1 here, that's just like this. There's a little invisible 1 that is my coefficient when it's not written. So follow the same step here. I'm going to subtract 5 on both sides. I'm going to get 1x, or just x, equals positive 11. Boom. Awesome. Donezo. Now with any of these, which you can do if you like, and if you have time, say like on a test, you're like, ooh, man, am I right? I've got like 5 minutes left in my test right now. You can check, right? I often go ahead and solve them if I'm on a test, and then if I have time, I go back and check them pending the problem that I'm working on. So I'll throw a 11 in here. I'll have 3 times 11 plus 5 minus 2 times 11. Let's see if we get 16, right? That's our hope. We got 33 plus 5 minus 22. 33 minus 22, I'm going to do that first. That gives me 11 plus 5. It does equal 16. So it checks out. Whee! Yay! I hope that didn't fall off the screen right there. Looks like we made it. Okay, I got a little screen on my watch here. Lovely, guys. So there we go. You can always check your solutions, especially if you have a little bit of time. But otherwise, if you guys have any questions, pop them in the comments. Thanks for watching this video. And, of course, stay positive, dogs. Have a nice day.